Ready? So good evening. So myself Yuvraj. So in this video lecture, I'm going to say some interesting facts about the introduction to engineering mechanics, the classification of engineering mechanics, the different branches of it. Along with, I'm going to share some ideas about how to resolve the given forces to find the resultant forces and based on what law. So we are going to discuss on Newton's law of motion and Newton's law of gravitation and so on and so forth. And I'm going to give you an introduction about free body diagram, which plays a crucial role in finding out the solution for the resultant forces as well. And then we'll be resolving the forces in a two-dimensional space. So with this brief intro, let me move on to the lecture. So we have the basic introduction, the definition for engineering mechanics. Engineering mechanics is a branch of science that deals with the behavior of body with a state of rest or its motion under the action of forces. So if I broadly classify engineering mechanics, it can be classified into two basic types. One is statics, another one is dynamics. So this dynamics gets classified into two major types, other that is kinematics and kinetics. Statics is the study of an object which is at rest. So statics means, so we can clearly write it as, so it is a study of an object at rest. So for example, dynamics, it means it is at motion. So if I want to find a force or study an object which is at rest, I consider that particular study as a static subject, and then if I consider the forces which causes motion, I consider that as dynamics. And broadly classifying dynamics into two more types, which is kinematics and kinetics. So I can classify it or define that as, if I consider the forces. So if I consider the force which causes the motion, I call that as kinematics. If I do not consider the force, right? If I do not consider the force, I consider it as kinetics. So to quickly say the slide in a nutshell, so the branch of science which deals with the study of an object or a body which is at rest or in motion is called as engineering mechanics, and it's broadly classified into two types. One is statics and dynamics, and that dynamics is subdivided into two more types, kinetics and kinematics. So to give a brief differentiation, so kinetics, in which the force is not considered; kinematics, the force which causes the motion is considered. Moving on to the next topic, the different laws of motion. So as we all know, the laws of motion plays an important role in defining the resultant force that's acting on a body. So the laws of motion definition, we have three different laws of motion, as we all know in our basic physics. So the first law of motion, a body will continue to stay in a state of rest unless until it is getting disturbed or getting acted upon by an external force. So it means an object stays in its original position unless and until it is getting acted upon by an external force which changes or tries to change its position from one object to another object. So and then moving on to the examples of that, the best example that I can say is keeping your books on a table. So unless until if I apply a force to move the book from that position to another position, I require a force. Otherwise, it remains in its original position. So moving on to the Newton's second law of motion. So we all know the basic equation for Newton's second law of motion is F is equal to mass into acceleration. So moving on with another perspective of this particular law. So we can define or redefine this statement in terms of considering the momentum aspect. So the rate of change of momentum of an object is directly proportional to the external force applied to it, and this particular change occurs in the direction of the applied force as well. So for example, if I want to keep an object, so I would require kind of an acceleration with respect to the change in time, so that the particular mass of an object is getting moved from one position to another position considering the force that is acted upon. So moving on to the third law of motion. So we all know the better way to understand the Newton's third law. For every action, there is an equal and an opposite reaction. So whenever there is a force exerted in a direction, we will be getting the equal amount of force towards the opposite direction towards an object. The best example would be like giving a rocket expulsion in which the fire is getting extinguished at the bottom zone and the rocket moves in the upward direction. So if there is a force exerted in the opposite direction, so you will get the equal amount of force in your way, right? Next, moving on to the very important topic, that is the Lame's theorem. So before moving on to the Lame's theorem, I would like to classify different types of forces, right? So I would like to classify different types of forces here for you. So before studying about the Lame's theorem, so let us discuss on the system of forces. So the different system of forces that is getting acted on an object, or different types of forces. So the broad classification would be like coplanar and non-coplanar. Suppose if the forces acting on an object is within the same plane of action, we consider that as a coplanar force. If it is not within the same plane, I consider that as a non-coplanar force. This is a major difference. Next, we will be having something called as concurrent forces. So suppose if I have different forces acting at a same point, so which means it is acting at a same point. So for example, I can give you a diagram representation for this. I have three forces. So one is force F1, I have force F2, and I have a force F3. So these are all getting acted upon at this particular point. So if it is acting in a single point, I consider that as a concurrent forces. So then we have like parallel forces and like parallel forces and so on and so forth. So like parallel forces acting in the same direction, unlike parallel forces, they are parallel but still in the opposite direction. So that is how we classify it into different systems of forces, right? Then moving on to the Lame's theorem here. Moving on to the Lame's theorem, it is applicable. Lame's theorem is applicable only for three concurrent forces. Okay, so Lame's theorem is applicable only for three concurrent forces which are coplanar in nature. So next, moving on to the Lame's theorem. So this Lame's theorem states that if there are three coplanar concurrent forces, I should be having coplanar forces along with it should all act at the same point. So it should be a three coplanar concurrent forces. Then each force is proportional to the sine of the angle between the other two forces. I can find the magnitude of the force by considering the trigonometrical function sine between the other two forces. So that is how we can find the magnitude of the forces for which if we are want to require to lift any weight in a tank or in a kind of pull any object from one place to another. So we can use depending on the number of forces acting along it. And then so next moving on to the resolution of forces, the last topic in this video. So we need to find the resultant forces and the direction at which that particular resultant forces is going to act on the object. For example, if I am considering a body in which I have three forces acting on, for example, I'll start with two forces then. So if I have only two forces, I can go with a direct law, that is parallelogram law of forces, and I have another law, that is triangular law of forces. So I can go by these two laws if I have two forces to find the resultant and the direction of the resultant. If I have more than three forces, if I have three or more forces, if I have three or more than three, I can go with Lame's if it is three, or I should go with resolution concept. So we should understand at which situation Lame's theorem should be used and at which situation resolution should be used. We can cross verify the answers so that we will be getting the same answers even if we go for Lame's theorem or resolution of forces. So let me give you an example here. So for example, So I have four forces here. So this is force F1, force F2, F3 and F4. So I have four forces of some values. Say for example it is 2 kilonewton. This is also with 2 kilonewton. And same here with 2 kilonewton and another 2 kilonewton force. So before resolving, I should understand the angle from which these forces are getting acted on. So now can I check with the usage of Lamy's theorem or not before proceeding with the problem? So I can count the number of forces here. I do have 1, 2, 3 and 4. So I think we cannot use Lamy's theorem here because Lamy's theorem is applicable only for 3 coplanar concurrent forces. So now I can go with the usual resolution concept. So the usual resolution concept has 4 major steps. The first step will be like summation H, summation V, and finding out the resultant using this formula summation H square plus summation V square. And the last step would be like tan alpha is equal to summation V divided by summation H, in which I can find the alpha value by taking tan inverse of summation V divided by summation H. So for all these, I would require the angle at which each forces are acting. For example, if this force is acting at an angle of 30 degree, this acts at an angle of 45 degree. This I have the force F4, it is acting at an angle of 30 degree from the vertical. So and this particular force F3 is acting exactly downwards. So before we move on to the resolution, we should understand the sign convention or the plus and minus convention, the sign convention. So I consider the upward direction to be positive, the downward direction to be negative, the right side direction to be positive, and the left side direction to be negative. So if I know all these sign convention, so the upward direction is positive, downward direction is negative, right side is positive, and left side is negative. So if I know this, it will be easy for me to resolve both all the forces horizontally and vertically. I can find out the resultant and the direction of inclination of the resultant. Next, moving on to the trigonometric functions role in finding out the resultant forces. So I do involve two trigonometric functions. One is sine, another one is cos. So what I am going to do with sine and cos over here. So in this aspect, so let me rewrite this question so that you understand it much better. So this force F1 makes an angle of 30 degree with horizontal. Force F2 makes an angle of 45 degree with horizontal. Force F3 is directly acting downwards. Force F4 is making an angle of 30 degree with vertical. So how am I going to use this sine convention and cos into my resolution concept? So if I want to bring in the sine and cos into this resolution concept, I think we should take the angle from the horizontal axis only. So that would be easy for us to understand the concept of resolution in a much better way. So this, I take this. So I have the first force, the angle is from the horizontal axis. I have the second force, the angle is from the horizontal axis. The third force, I don't have any angle, so that I can resolve this force either in left direction or right side direction. So let me use a different color so that you understand it much better. So I can resolve this force, this F3, either in left side or right side. Now moving on to the fourth force, I have this angle 30 degree made with a vertical. So as I said, if I want to go with sine or cosine formula in this resolution, the angle should be from the horizontal. So it is 90 minus 30, 60 degree for the force F4. Now I can resolve the forces based on the subject knowledge which I am going to share with you right now. Now the first step will be summation H is equal to. So if I consider for horizontal resolution, I can consider only cos theta if I have the angles with respect to horizontal axis. I can take only cos theta if I have the theta value taken from the horizontal axis. Wherein if I want to go with summation V, I can use sine theta so that the same angle lies with respect to the horizontal axis. Let us see an example for the same. So summation H. I want to resolve this first force. I can resolve like this. F1 cos, what is the theta made by the first force? It is 30 degree. Now, I said the direction, the importance of direction in resolution. It is going towards the right side, which means it is positive. Now coming to the second force, it will be minus F2 cos 45 because it comes in the direction of left side. So it will be minus F2 cos 45. Next, moving on to the third force, I have two directions in my hand. I can either take it to the right side or left side. So whichever direction is comfortable, we can take and resolve the force. I am taking it to the positive direction. So it is plus F3 cos 90 degree. And if I move on with force F4, I can resolve to the nearest axis F4 cos 60 degree. If I simplify this answer, I'll be getting an answer for the resolution of force in horizontal direction. Next, how to resolve these forces in vertical direction. Again, as I said, we can go with the sign convention, trigonometry sign convention, with the same theta taken from horizontal axis. We'll go with the first force so that we have to take the sign convention for this direction, upwards and downwards. If it is horizontal, we consider right and left. If it is vertical, we consider up and down. So first force, it is going in upward direction. We can write it as F1 sine. What is the theta that we have taken here? It is going to be 30. So you should not get confused that this angle should be written here, because I said clearly that resolving forces using sine and cosine taken from the theta value from the horizontal axis, it depends on the trigonometric value. So for example, if it is summation H, I can go with only cos theta. The cos value, the theta should be taken from the horizontal axis. Now coming to the second force. Second force, it will be in the positive direction, F2 sine 45. Next, I have the third force going extremely downward. So I can write it as minus F3 sine. So it will not be 0 degree. So what is the value that you have written here? It is 90. So it can be 90 here also. Now coming to the last force. If I resolve this force, it will be minus F4 sine. The angle will be here 60 degree. So now if I substitute the values of the forces and substitute the values of sine and cosine value in the calculator, I will be able to find out the values of summation H and summation V. So from these two values, I can now find the resultant. So the resultant formula will be like summation of square root of H square plus summation of square root of V square. Summation H square plus summation V square. Next, if I want to find the direction, so as I said here, if I want to find the direction, I can use this formula where this is the direction of inclination. Direction of inclination. So it is tan inverse of summation V divided by summation H. So by this way, we can resolve any number of forces given on any object, that is acting on any object, to find the resultant and the direction of the resultant force acting. Thank you.